grade 12, so on to topic 6, which is just basically a mixture of some random circle type questions that can come up. So first example gives you the equation of the circle, and it tells you that it's translated 3 units right and 2 units down, and I need to determine the new equation. Now I think the most important thing to realize is that when you translate a circle, what's the only thing that it's affected? It's only affecting the center of the circle. Of course the entire circle moves, but in terms of characteristics of a circle, we have the center and the radius. Now the radius won't change. So basically I need to move 3 units right. Now when you move right, you subtract 3, and I need to move 2 units down. So now this is when it starts to become a little bit tricky, because you would take the opposite sign. So the center of this circle, for example, let me start with this. The center of this circle is 1 and negative 2. So personally, I write down the center, then I translate it, and then I go put it back. Simply because if you think, oh, I need to move 2 units down, you would think, oh, I need to minus 2. So you would minus 2 in the circle. I mean, in the bracket. So you would get 1 plus 2 minus 2, which is just, sorry, y plus 2 minus 2, which is just y. But just be careful. Let us take the center of the circle. If we translate 1, 3 units right, that goes to 4. If we translate negative 2, 2 units down, that's negative 4. So you'll notice actually it isn't a minus 2. So just be very careful. This is happening because the signs inside the brackets are opposite to what the circle center is. So always actually go find the circle center and then go put it back in the equation. Otherwise it leads to all sorts of problems. And so that is my new equation. Okay, now if we try another one, this example, the only reason why it's more difficult is that you have to complete the square. Now we've gotten so good at this. So this is x minus 3. So that's from that over there. But that means on the other side, I'm going to have to add 9 when I eventually get there. So this is plus, and this is going to equal to 10 that was originally there. Now this part here must have come from y plus 1 squared, but now I've added 1 to both sides. So now I can write down my center of this current circle. Currently my center is at 3, negative 1. So that's going to become, if I go 5 units right, this will go to 8. 2 units up, this will go to 1. So therefore, my circle's equation is x minus 8 squared plus y minus 1 squared, and that's equal to 10, 19, and 20. Great, so those are your translation type questions. Okay, now some other just random ones that I made up. Determine the equation of the circle with center 2, 3, which is tangent to the x-axis. Now this is a classic example of where I would really encourage drawing this. So 2, 3, I don't really know where it is, but let's pretend it's there. So this is 2, 3, and so my circle is going to go around, and apparently, I don't know where I go, but I know I'm tangent to the x-axis. Now I know the center, I just don't know the radius. But I hopefully know that that is a radius, and careful, a radius is always perpendicular to a tangent. So now that I've drawn that in, I'm sure that I can tell you the length of this radius simply by looking at the coordinate of my center. My center is 3 units up from the x-axis because the y value is 3, which means this radius is 3. So therefore my equation of my circle is actually quite easy, but only if I'd drawn a picture, otherwise I wouldn't have seen this. So this has to be x minus 2 squared plus y minus 3 squared, and this is going to be equal to 9 because I know my radius is 3, so I squared my radius. So picture absolutely essential. Right, let's look at another one. Determine the equation of the tangent or tangent, so it could be more than one, to x plus 1 squared plus y squared equals 20, which is parallel to that. So, I don't know, I will draw a picture. I just find it easier to work with. So basically the circle that we're looking at is going to have a circle center at negative 1, 0. And so I don't really know what the circle looks like, but it's going to be something like that. Now my tangents are parallel to, if I just isolate my y, they're parallel to y is equal to a half x. Now a half x is going to go straight through the origin, and a half x might look something like that. So basically I want the tangents parallel to this. So immediately I can see where those would be. So there could be a tangent that goes here, and it's parallel, so it has some random point of tangency. And so far I know that that would be y is equal to a half x plus c. And then this is why they said there could be more than one, because I could also go to this side, and that would also be y is equal to a half x, but I'm going to write plus d, simply because they wouldn't have the same y-intercept. So yes, there's two tangents, and both of these are parallel to y is equal to a half x. Okay, now to be honest, that's the easy part of the question. The hard part is now I need to know both of these points of tangency, because that's the only point that I'm going to have on these tangents. And I need a point on the tangent in order to find d and c. So how do I get that point? I know absolutely nothing about these tangents other than their gradient. I also don't know the x and I don't know the y, so it sounds like a simultaneous. So I always go back to what's the only thing I know about tangents. I know the tangents are perpendicular to radii. So if I draw basically a diameter, I know that this is perpendicular, which means I know that the gradient of the radius, or the diameter, whatever you want to call it, is -2. Okay, now that again doesn't help me much, because I know the circle center, yes, I know that point there, but I don't actually know the x and y of the point of intersection. So knowing the gradient, I can't solve backwards from gradient because I don't know x and y. However, I can work out the equation of this purple line that I've drawn in. I know this is y is equal to 2x plus, and now I've used c and d, so why not call it e for lack of a better letter. Now I have a point on this purple line in that it's -1, 0. So 0 equals -2 times -1 plus e. So e is equal to -2. So therefore I know the radius has the equation -2x minus 2. Now how does that help me? These two points of tangency, so this point which I'm going to label A, and this point here which I'm going to label B, which I need in order to continue, those are the points of intersection of the circle and the tangent, yes, but I don't know what the tangent is. But they're also points of intersection of the circle and this y is equal to -2x minus 2. So now, if I can go do a simultaneous equation between y is equal to -2x minus 2 and the circle equation, which is x plus 1 squared plus y squared is equal to 20, to find a and b. Once I found a and b, finding these equations is easy. So this was the hard part, figuring out how to get a and b. Simultaneous equation isn't too hard. So if I solve this simultaneously, let me square out the brackets, so I get x squared plus 2x plus 1, and then it's plus y squared, so now it's plus -2x minus 2 squared, and that's going to equal to 20. So actually x squared plus 2x plus 1 plus 4x squared plus 4x plus 4 is going to equal to 20. Sorry, it kind of almost gets lost there at the end. So I get 5x squared plus 6x. 1 plus 4 is 5, minus 20 is minus 15, equals 0. Now as I've just worked this out, I've realized I've made a mistake in that this, when I put 4x here, I actually meant 8x. My apologies. So actually I get 2 plus 8, which is 10x. Now that'll be far easier for me to factorize. So I divide by 5, and I get that. And listen, my hint here that I'd made a mistake is that I factorized that quickly in my head and I couldn't factorize. So I got irrational solutions, and I'm not saying that irrational solutions are always wrong, but in a question where I would then have to go and use these x values to find an equation of a tangent, that just seems a little bit cruel. So the moment I get irrational values, I always just check. If they are irrational, then I just accept it and move on. But I'm always a little bit nervous in this situation where you actually need to carry on and use this. So actually I get -3 and 1, which actually looks fairly plausible. And now I need to know why. I would use my straight line equation, much easier. So if I went and substituted in -3, I would get y is equal to 4. So I know that the coordinates that I'd labeled A are -3, 4. And if I go and put in 1, I get -4. So I know that B is the coordinate 1 and -4. And now it's fairly easy to continue. So I know it's a half x plus c and d. So for this one over here, I know it's y, which is now 4, is equal to a half x plus d. So I'm hoping I didn't make a mistake this time, but I get 11 over 2 is d. So y is equal to a half x plus 11 over 2. And for this one over here, I get y, which is negative 4, is equal to a half x plus c. So here I get c is negative 9 over 2. And so y is equal to a half x minus 9 over 2. And if I look at my picture, both of those seem plausible. You know, negative x-intercept for the orange line, negative y-intercept for the orange line, and positive y-intercept for the blue line. So those look all possible. Now, this was a mean question. This was particularly tough, but a really, really nice question. Okay, onward to some more nice ones. This one's quite a nice one. The equations of the tangents to the circle, and again, I always draw it. I just find my brain can think better. So x squared plus y squared equals 72 will be a circle centered at the origin with a certain radius. And apparently, I want to know the equations of the tangents that have an angle of inclination of 135 degrees. Now, you can immediately go and work out what gradient that means, because tan of 135 degrees would be your gradient. Now, that gives you negative 1. So basically they're saying they want the equations of the tangents, and here's the tangent that has a gradient of negative 1. So it must be both of those. There's my angle of inclination of 135, just to show you. And on this side, there's my angle of inclination of 135. And so I know that both of these, now this is sounding very similar to the last question. So this is y is equal to negative x plus c, and this is y is equal to negative x plus d. So this is sounding very similar indeed. So I need my points of tangency. So where is the radius that will be perpendicular? My radius that will be perpendicular is there. Now this is where this one's quite a nice question. This is x squared plus y squared centered at the origin. And so this gradient will have a gradient of 1 because it's perpendicular to the other gradient. But I immediately can tell you it's y is equal to x because it goes straight through the center, which is 0, 0. So that makes it a little bit easier. So basically now, in order to find these 2 points of intersection, I need to do a simultaneous equation exactly like the previous example between these two. Where does that radius kind of line hit the circle? Now this is quite a lot easier because it's x squared plus and y is x. So it's x squared plus x squared is 72. So I actually get 2x squared is 36. So I get, sorry, not 2x squared. 2x squared is equal to 72, which means x squared is 36. So x is plus or minus 6. So this coordinate here is positive 6, and this coordinate here is negative 6. Now don't forget this is on the line right as x. So it's negative 6, or 6, 6. So this is exactly the same kind of method as the previous question. So this one here, negative 6 will equal to negative 1 times negative 6 plus c. So negative 12 is equal to c, and this tangent is equal to negative 1x or negative x minus 12. Whereas this one is 6 is equal to negative 1 times 6 plus d, and so d is 12, and so this is equal to y is equal to negative x plus 12. Now this is a particularly good exam question because the concept is being tested as it has in example 4, but this mathematically was easier because the simultaneous was easier, finding the equation of the radius was easier. So this is a particularly good exam question. Okay, last example for this kind of weird section on different type questions is example 6. So example 6 gives us 2 circles, and unfortunately they're both not completed the square. So first question says find the center and radius, not a problem. So first one, if I complete the square, you start to get really good at this. So I get x plus 2 squared. These two together, I get y minus 9 squared. And this is going to equal negative 80 as there was, but I added 4 to both sides when I completed the square, and I added 81 to both sides when I completed the square. So actually this is going to become 5. So therefore my center of circle 1 is at negative 2, 9, and my radius is equal to root 5. Now if I just do the second circle next door to it, x, or now it's a little bit more tricky because first I would want to bring over my x's to the side, so it's plus 12x, and I'd want to bring over my y's, so minus 2y, and that'll equal 8. So now that's a little bit easier. So these two would complete the square to x plus 6 squared, and these two would be y minus 1 squared. Now that's apparently equal to 8, but I've added 36 to both sides, and I've added 1. So this is going to simplify down to 45. So therefore the center of this circle is at negative 6, 1, and my radius here is root of 45, which I can simplify because simplest third form, I don't have to, but simplest third form is 3 root 5. Okay, so that was question A. Question B, really good question. Prove the circles touch one another externally. Now, what does that mean? What that means is these two circles are going to touch each other on their circumferences. They're not actually going to intersect one another. So if I just try and draw this type of situation, negative 2, 9 would be, a center round about there. Negative 6, negative 1, maybe I should actually draw this a little bit more over, simply because those are quite negative. So if I try again, negative 2, 9, let's pretend it's about there, negative 2, 9, and negative 6, 1, let's pretend it's about there, negative 6, 1. Now that means that there's a circle around there, and there's a circle around here. Now in order to touch externally, it means that where their two circumferences hit each other, they touch. They don't miss each other, number one, and they don't intersect one another. So the two other options could be that my circle could be smaller like that, in which case they wouldn't touch each other. Or you could have a case where this circle was bigger and then they would hit each other twice. So how do you show which one it is? Okay, now this comes down to one thing. Here, that is the radius of the one circle. So this is the radius of circle number 2 actually. And this is the radius of circle number 1. Now that would be a perfectly straight line because this is a tangent over there, and that's at 90 and that's at 90. So this would be a perfectly straight line between the two circle centers. Now I know what that distance is because I know what I think it is. The distance of the radius 1 plus the radius 2 is equal to 1 root 5 plus 3 root 5, which is 4 root 5. So if you add the two radii together, the distance between them, the two radii, is 4 root 5. So the distance between the two centers should be 4 root 5 if they touch each other. If we had a situation where the circle intersected like that, what would happen is that your circle center would be, your two radii would be longer than the distance between the two centers, because the radius would be all the way to the end, and then this radius would be all the way to the end, and you would be counting a little bit of space twice. So in that particular case, the distance between the centers will be shorter than the two radii together. So in this particular case, if I just erase that, if I work out the distance of the two between the two centers, so what is the distance from between the two centers? If I work that out using the formula, this is negative 6 minus 2, so squared, plus 1 minus 9 squared. No, not squared, wrong place for my squared, let me put it outside. And if I work that out, guess what? I get 4 root 5. So that means the distance between this center and this center is exactly 4 root 5, which is the same as the radius of the one plus the radius of the other. So there's no ways they could be separate. If they were separate, the distance between the two would be bigger than the two radii together. And if they were intersecting, the distance between the two would be less than the two radii together. So simply because the distance between the two equals the radii together, that means that these two touch each other, what we say, externally. They're tangents to each other. So really nice. We'll see more of these type of questions when we look at past papers, and this is going to be really where we get really good at analytical geometry, where we do quite a lot of past papers.